Hello everyone, welcome back to another lesson in our Python Fundamental series for machine learning. This is lesson 7, whereby today we're going to be taking a look at what is known as pandas. When I say pandas, I don't mean the cute black and white animal, but a toolkit for Python in working with machine learning models. So without further ado, let's get right into it. So what is pandas? Pandas is like Excel essentially for Python, but it's more powerful. It lets you load data sets, explore them, clean them, and get them ready for machine learning. So what can you expect? Labeled data structures, which help you to organize your data with meaningful labels. Easy file loading, so you can import data from various formats with very minimal code. And you can transform and analyze your data efficiently. So what code do you use in order to begin using pandas? We have what is known as the import method. So you import pandas, and then we again have this as keyword, so that instead of having to reference pandas every time we want to use pandas, say pandas dot blah blah blah, we can just use pd in order to reference the pandas toolkit. Okay, so we usually import pandas as pd. It's short and saves typing. Most examples and documentation follow this convention. Next, we're looking at data frames. So what is a data frame? The core of pandas is the data frame. It is a table with rows and columns like a spreadsheet, and it's perfect for holding and organizing structured data. And so here's an example of how you create a data frame below. So we've imported pandas. We've got a bunch of data here, so a list or key value pairs of name and some different ages of Alice and Bob, and then we've got data frame is equal to pd dot data frame data, and we're then printing this data frame. Okay, we can also add, for example, CSV files. So most real world data comes in a CSV format. With pandas, loading a CSV file is as easy as one line. So now you're ready to explore and analyze your data. Okay, so here's just some different methods of things that you can do with your data frame within pandas. So these commands help you to inspect your data set. You have the head, for example, tail, shape command, info, describe, etc., etc. Okay, accessing different columns. So you can access columns either like a dictionary, or you can use dot notation. Both will give you the column as a series, which is a one-dimensional version of a data frame. So you can access columns using square brackets and the column name as a string. It works with any column name required for names with spaces, and it's more explicit in code. Or you can use a dot notation. It's shorter and cleaner in terms of its syntax, only works with valid Python identifiers, and it cannot be used with spaces in names. To access rows, you use the iLock for location or position, and .lock for label. So this lets you zoom in on specific parts of your data. You can also filter data. You can filter by rows by writing conditions. And here we're selecting only the rows where the age is greater, indicated by this greater sign here, than 25. This can be super useful for exploring and comparing different data patterns. Okay. You can create new columns based on existing data. This is helpful for flagging or categorizing data, like marking senior citizens in this case. Okay. We can also directly modify columns, useful for things such as applying formulas, normalizing data, or making corrections. Okay, so we started with an original data value, defined how to change the value, update the column in place, and the data now reflects this change. So we started with the data frame of age, and then we've added to that age, let's say 25 plus 1. Handling missing data. Missing data is common in real-world data sets. Pandas makes it easy to either remove these rows or fill in missing values with something meaningful. So we have the df.dropNA, eliminates rows with any missing value. It's clean but may lose data, can specify columns, use access parameter for columns, or we can use this command here, which is the fill command, which will replace any missing values with this specified value in brackets here. Preserves all data points. It can use mean, median, or mode, and can fill different values per column. Right, we can also sort data. So you can sort your data frame by any column, and this is very useful when you want to quickly find the highest or lowest values, for example. Alright, so we can go here. You look, sorting our data. So we can also sort our data frame by any column. This can be especially useful when you want to quickly find, say, the highest or lowest values. So we've got data frame and we've got the dot sort values method, and we're sorting by age. In ascending, we set to false. Hold on, we set by age. Sorting our data. So you can sort your data frame. Next, we have sorting our data. So you can sort your data frame by any column. This can be particularly useful when you want to quickly find the highest or lowest values, for example. So you have, again, the data frame that we're working with, and we have now this sort values method, and what we want to sort is the age. Grouping data. Grouping lets you summarize data by category. For example, here we're calculating the average age for each job group. This can be super powerful when it comes to data analysis. Once your data is ready, save it to a file using 2CSV. This lets you export your clean data and use it in machine learning models, or you can share it with others. And we do that using the 2CSV method like so. So before we go on to some practical examples, let's just do a quick recap. So Pandas helps to load, view, and clean the data. It's essential for data preparation. We use data frames for structured data. It helps to filter, sort, and group data easily for flexible data manipulation. It can handle missing values easily. Clean data is better. And we can save our results for machine learning in a CSV format.